Okay, let's work some sample problems from section 1.6, inverse functions. Number 10, they want us to show these two functions that they give us are inverses of each other. X minus 9 over 4, g of x, 4x plus 9. So remember, to find the inverse, or to prove that two functions are inverses of each other, you need to find f of g of x and g of f of x. You need to do both of these, and they both need to equal x. So first let's find f of g of x. Okay, I'm going to take g and I'm going to put it right in there for x. F of g of x is x minus 9 over 4, but not x. We're going to replace x with 4x plus 9. And 9 minus 9 is going to be 0, so we have 4x over 4. And the 4's cancel each other out, so we're left with x, so we're halfway there. G of f of x is equal to, so here's g, that's 4 times x plus 9, but again, not x, but x minus 9 over 4, that's f of x in there. Let's see, we cancel out the 4's, we're left with x minus 9 plus 9, and that's just x. These guys cancel each other out. Okay, so they are inverses, and our job here is done. Go on to number 28, and they want us to do the same thing, so let's just get another practice in. F of x is equal to x plus 3 over x minus 2. G of x is equal to 2x plus 3 over x minus 1. Alright, so f of g of x is going to be x plus 3 over x minus 2. And here's what's going in place of x, that's g of x. And we make that substitution again. Alright. Well, we've got to, let's see, add 3 to this thing here. To be able to add 3 to this fraction, we've got to get common denominators. And to get a common denominator, we're just going to have to multiply this by x minus 1 over x minus 1. And the same exact thing here. Get a common denominator for the 2. And now let's distribute this, and we'll write it just above that. So this will be the distributed version. 3x minus 3. This here is going to be 2x minus 2. So let's combine them together. 2x plus 3x, that'll be 5x, plus 3 minus 3, so that's nothing is left, over x minus 1. Right, and now 2x minus 2x is no x's, and 3 minus a negative 2, that'd be 5, over the common denominator of x minus 1, multiplied by the reciprocal, 5x over x minus 1, times x minus 1 over 5. Also, the x minus 1's cancel each other, and x is all that's left. G of f of x. G of x is 2x plus 3 over x minus 1. And we're going to make this substitution a couple times again. Alright. So up here, we're multiplying 2 by this fraction. you can think of 2 as being 2 over 1. We're going to multiply straight across, which means distribution. So up here we have 2x plus 6 over x minus 2 plus 3 over just what this is. So since we don't have to do any distribution, let's do this step here that we did similarly up here. Need a common denominator, so that's going to be x minus 2 over x minus 2. Multiply 1 by x minus 2, and it's just x minus 2. So as we go to rewrite this, let's do the subtraction. X minus x, nothing. 3 minus negative 2 would be 3 plus 2. That would be 5, and that's all over the common denominator. Alright, we're going to have to multiply this by x minus 2 over x minus 2. This is going to turn out to be, when we distribute, 3x minus 6 okay. 2x plus 3x would be 5x, and 6 plus a negative 6 would be nothing left. That's over x minus 2. Something very similar is happening. This is 5 over x minus 2. We can see something very familiar is happening here. We got 5x over a denominator and 5 over the same denominator, and we could multiply by the reciprocal and find that everything cancels but x is left. Okay, that was 28. Now we'll go on to 23. Now 23, we're just going to do one of these. There's 4 of them in this set, but we're going to do the decision making for 23. So for 23 and also the other 3 that are with 23, there are 4 graphs. One looks like something like this, and one looks something like this. This one looks like that, and like this. Okay, and then our graph for 23 that we're supposed to, actually do something with looks like this. And we are supposed to decide, this is supposed to be the inverse of one of these functions. And in short, the graphs of 2 inverse functions are going to be reflected over the y equals x line. Right? If this y equals x line were a mirror, and I reflected this graph over it, what would it look like? Well, it probably wouldn't look like this or this. These are lines, so that doesn't make a whole lot of sense. This has another piece to it. It goes over the origin and keeps going, and this doesn't. So it's got to be this one, by process of elimination. And we should be able to see that if I were to reflect, if I imagine that I skewered this graph, ran a pole through it or something, and I just spun it around on that axis, this part would come and flip up here, and this part would come around and flip down into here. And that's what it would look like. So that is, of course, A, and that would be, what we would answer, A. 61. I'm going to find an inverse. Alright, this is 61. F of x is equal to x to the 5th. And we want to find the inverse. Okay. Remember that inverse is like if we ran the factory function in reverse, right? Let's make this a y, so it's a little easier to talk about in this context, right? Usually in functions I put things into the x, do stuff, and they come out the y, right? This is like the door into the function and the door out of the function. If I run it in reverse, I'm going to go in this door and come out this door. So I'm saying that in words. We're going in this way and out this way, so let's just write that in, using this notation that we use for functions. Okay, and then we don't like our functions to be x equals y. We like it to be y equals x. So let's solve for y, which would mean taking the fifth root of both sides. So y is equal to the fifth root of x. That's the function. Lastly, we'll do number 68. We'll just go over this process again. F of x is equal to 6 over the square root of x. And just a note about this. Remember, let's go back to function notation, and this will be how we say that this is the inverse. If this is if this up here is f, if this is f, then the way we say that this is the inverse is to put a negative 1 up here like this. Alright, for this one, let's say so y equals 6 over the square root of x. I just changed the f of x into a y. And then, sorry, my computer's being a little jumpy and glitchy. Okay. Okay, sorry that I changed the battery in my tablet there, and it's all good now. So we replaced f of x with y, and now we're going to switch. Remember the indoor and outdoor. We used to go in this way and out this way, and now we're going to go the other way. So we are going to switch the in and the out. Now we need to solve for y. For one thing, y is on the denominator, so let's solve that by multiplying by the square root of y on both sides. And at the same time, let's divide by x on both sides. That cancels out. These are canceled out. So we've got the square root of y is equal to 6 over x. And to get y by itself, we square both sides, so y equals 36 over x squared. Okay, so that should do it. I hope that was helpful.